So welcome to Lesson 9C. Before we get started, think about when you've had job interviews. And did you talk about salary? And did you negotiate for a higher salary? Right here it starts talking about when choosing a profession. There are several questions related to finance that could be relevant and need to be considered. Here are some questions. Salary. What am I going to be doing after 5 years? Advanced degree. Good. Better, not going to make a difference? Is it worth the time, the effort, and expense? What other questions should you consider important, or would you consider important, in anticipating or accepting a job? This is a great time to hit pause, jot down some thoughts on question 1, and read 8 tips to negotiating a higher starting salary. When we're finished with this lesson, you will understand that visual displays, such as scatter plots and histograms, can be used to represent univariate and bivariate data. And think about a unicycle or a bicycle, and they have either one wheel or two wheels, and variate meaning variable, so we'll be dealing with one variable or two variables. When two variables are related, the relationship can be described in terms of a correlation. We're going to be able to create a line graph for univariate data, line for univariate. We are going to be able to determine informally the correlation between bivariate data, and we're going to analyze data and related graphs and describe the trend of the data. In this lesson, we're going to be talking about years of experience in a career and salary, and those are two variables. We'll be focusing on those variables, and we must know whether we're going to be dealing with univariate or bivariate data in order to determine the appropriate numerical analysis and graphical display. I would read the paragraph about researchers at George Mason, and I would go with question number 2. If you haven't already read it and you haven't hit pause, go ahead and do that and come back and we'll walk through some of it together. So they conducted a study and they examined effective negotiating strategies that would increase job candidates' starting salary, and if it did it by an average of $5,000. Assuming an average annual salary pay increase is 5%, an employee whose starting salary was $55,000 rather than $50,000 would earn an additional $600,000 plus over the course of a 40-year career. One of the assumptions listed in the quote is an annual pay increase of 5%. How likely is that you're going to average a 5% annual pay increase? And some thoughts on that are that the economy does go up and down, and it seems very unlikely that someone's going to get 5% every year. This is a great place for a reminder that you have out your pages from your in-class notebook printed and you're writing on them and highlighting and underlining, maybe even making a glossary or flashcards as we go through the lesson. And then make sure that you are hitting pause and that you're doing the problems before we go through them together. Question number 3 especially. Go ahead and read question number 3. Look at parts A, B, C, and D. Do them first and then come back and we'll talk through them together. Research on the internet can find numerous studies about compensation levels for various professions. Such research is not only valuable for the job seeker, but also the job provider, since the supply and demand economic model determines to a large degree starting salaries. The American Society of Civil Engineers and the American Society of Mechanical Engineers conducted a joint engineering salary survey, and they published their findings. This report includes a great deal of information about salaries of engineers. Read each excerpt and determine the type of data being discussed. As you read through Part A, as of March 31st, the average total income of respondents in the survey was which included salaries, fees, cash bonuses, commissions, and profit received from the respondents' primary jobs during the preceding 12-month period, but specifically excluding overtime pay. And so the question is, through that whole paragraph, did we talk about one variable or two variables? The answer is we talked about one, only talking about the variable of salary. Salary included a lot of pieces and parts, but ultimately it was just salary. Part B, full-time salaried respondents holding doctoral degrees in engineering have a median income of, hang on, salary, a degree, and an income that goes with that. Those with a Master of Science in Engineering earned a median degree or an income of $95,000. And those with a Bachelor of Science earned a median income of $85,900. So the question now is this one a demonstration of univariate or bivariate? And we have a new variable introduced. So not only is it salary that we are discussing in this paragraph, but it's also your degree, because the degree is influencing your salary. Continuing on with part C, median income shows a consistent increase with increased engineering experience. Is this one univariate or bivariate? And again, it's talking about income or salary, but it's also talking about years of experience. The more years of experience probably is going to impact your income, your salary. And then finally, part D, Exhibit 12 reports income by professional responsibility engineering grade. The graph shows the shape expected rising from a full-time salary medium income of an engineer 1 to this income for an engineer 8. Univariate or bivariate? Well, again, they're talking salary, but this time they've introduced a new variable called your grade, because your grade, like a level 1, is going to make a certain salary, whereas a level 8 is going to make a different salary. Make sure you've got your glossary or flashcards out and you're ready to add to them, maybe a Google Doc that you're collecting all of these vocabulary words and processes on. In previous lessons, you examined what statisticians call univariate data. That is, you calculated statistics on a single variable, one data set. Like we've been studying temperatures in San Francisco and St. Louis and the consumer ratings for treadmills. Univariate are quantitative if the individual observations are numbers. A quantity, numbers. These variables in context usually have units. Univariate data can be numerically analyzed by, you can find measures of central tendency, like you can calculate the mean or the median. You can also look at the measure of spread, like the range. What's the highest number, what's the lowest number, and you can subtract the two. We are often interested in how many data points fall within a given attribute, like a category or a class, or even maybe like a bucket or a box, a bin. Things that this can include, or the tools will include frequency, and we can use tables and graphs. We can do dot plots. We can do histograms. We can do box plots based on categories or class. It's time for you to hit pause, go do question 4 and beyond, or as much as you want to bite off for right now, and then come back and work on this with me. Looking at question 4, it mentions that the report of the Joint Engineering Survey of Salaries mentioned it includes the information shown in the table below. Let's look at what's going on, like there's an annual income. We have experience. We have some number who responded. And then we have some information like how many or what salaries in the 10th percentile, in the 25th, the median, the 75th, the 90th. Using the data from the table, construct a number line beginning at $0, ending with $100,000 with tick marks at every $10,000, and place a solid dot at each of the 4 percentiles and a solid square at the median. I'm going to go ahead and read part B before I take off on this. Using the same data, construct a new number line, but this time we're going to begin at 50,000 and end at 110, whereas this one begins at 0 and ends at 100,000. Still the same tick marks every 10,000, but we're going to place a solid dot at each of the 4 percentiles and a square at the median, and then they want us to compare and contrast the two figures. Part A, oh, that doesn't look good. Let me try this again. I'm just going to work this question back on the problem itself. So starting with part A, it says use the data in the table to construct a number line. So I'm going to freehand a number line. It asks me to start at 0 and go up to 100,000, tick marks at every 10,000. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And so here's 10,000, 20,000, etc. Again, pause if you haven't already done this. It asks us to go ahead and place a solid dot at each of the 4 percentiles. So let's do a solid dot at each of the 4 percentiles. We've got 56, 1, so about-ish right here-ish. 63, 6, so somewhere about right there. So those are percentiles. 84,000, about right there. And then 97,000, about right here. Then it asks us to place a solid dot at each of the 4 percentiles and then a solid square at the median, which is 72, 3. So about right here. Okay, done. Then it asks us to draw it again on part B, and this time they want us to use the same data, but they want us to draw it differently. They want us to start at 50,000 and go up to 110,000. So 60, 70, 80, 90, 100, 110. And so here's 60,000, 70,000, 80,000, 90, 100,000, and 110,000. And they want us to do the same thing. They want us to do solid dot at each of the 4 percentiles. So here we go with a solid dot. A solid dot at 56, 100, 63, 6, 84, and 97. And then a solid square at the median of 72. It asks us to compare and contrast on part C. And it depends on how I could have drawn this one. I could have spread it out the entire length of the other one. But what it boils down to is on part C, compare and contrast. Write your own pieces and parts and thoughts. So a sample thought is that the two figures give different impressions about the annual income. The first one shows that the engineering salaries are pretty high, and there's not much difference between the quartiles. Everything's kind of close together. But then, and especially if I had made this bottom one more spread out, like made the 110,000 all the way over to here, then it would look like they're more spread out, and even this looks like they're way down here at the bottom. With it out at starting at 0, it's distorting or making it appear different, even though it's the same data. So that was just looking at univariate data. We're going to move on and talk about bivariate. In other words, two variables. When examining bivariate, we often want to know how the two variables relate to each other. For example, educators may want to know if reading scores are related to math scores. That is, whether students who have high reading scores also have high math scores and vice versa. In an earlier lesson, we read that the statistical term for defining the degree to which variables are related is called correlation. When two variables are strongly linked together, we say that they have a high correlation. We have positive correlation and we have negative correlation. When higher values of one variable are paired with higher values of another, in other words, the higher the temperature is outside, the more that people show up at the beach, there is a positive correlation. Negative is when higher values of one variable are paired with lower variables of another, like when the higher the temperature is outside, the less coffee is going to be sold at a coffee shop. Make sure that you do question 5 by yourself. So hit pause, go take care of working through and just getting down some answers, putting a lot of thought into what you see and what you're reading, and then come back and we can work through it together. The report on the Joint Engineering Survey also includes this information. It mentions that annual income, years of experience, salary, under 1 year, 1 to 2 years, etc. So part A, what do you think are the two variables in this table? However you want to say it, whatever it makes sense to you, but your years of experience. And remember, also be thinking even along the lines of a graph. One of them is going to be on the independent axis, one's going to be on the y-axis. With one being independent, it is impacting or affecting the other, which is the dependent. And so we have years of experience, and then we have salary. Which one is acting independently? Years of experience are what you'll choose, select, have, and your years of experience are going to impact the amount of salary that you earn. Part C asks us to construct a scatter plot. Then D says examine it, describe the correlation, what's going on, what would you say about the relationship, is it positive, is it negative, and then even thinking about another way to display the data, and are there outside variables that could impact what's going on. So let's start with construct a scatter plot and examine it. So here's a pre-made scatter plot which has years of experience on the horizontal and average salary on the vertical. They ask us to examine the scatter plot and determine the correlation. Would you describe the relationship as positive or negative? Look back at how we defined this a while ago. But as the years of experience are going up or getting higher, the average salary is also getting higher. So yes, positive. And there appears to be a high correlation between the two variables. Part E, what would be another way to display this data? You could do a bar graph and a bar for each of the categories. Whatever you'd like to write down, it just needs to be able to handle bivariate. 2 pieces, not just one. Part F, what other variables might be affecting this relationship or this great correlation? And it could be where you work, what region of the country, the quality of your work, the size of your company. Multiple factors can impact your salary. And this concludes our lesson. This is lesson 9C. You need to go look at your syllabus to see if you have any more lessons that are due this week. If there are, keep going. If there are not, I'll see you again soon.